$300 of electronics inside, and that's going to north of $1,000. This platform is really changing over time. You're seeing connectivity not just be in the car, but spreading outside the car. You're seeing technologies like V2X that will create car-to-car communications. You're seeing intelligence coming to the market already. Those of you that have newer cars see some of the features in terms of lane, making sure you stay in your lane, warning when cars are coming near you, those kinds of things. You're already starting to see some of the features. We have a ways to go. Self-driving cars will take time to evolve, and to actually have cars that literally drive themselves. But you'll see iterations of this process over the next several years, and it's really a very exciting time for the industry. And the speaker after me is going to talk more about what Qualcomm's doing. And then we also have one of our presenters on a panel coming up, Chris Bird, who lives in Detroit, is very involved with the auto companies there, talking about what he sees from that side. So, obviously, one of the things we see is if we take ourselves out of the equation in terms of driving and turn it over to the machines, assuming the machines get to a point of high reliability, you'll see a significant improvement not only in lives saved, but also in productivity. Simply thinking about how inefficient cars move around when you're in traffic. If you were to synchronize them more tightly, you could get a lot more efficiency out of traffic pattern movement. Obviously, lower gas emissions as well. Qualcomm, we are leading this area. You might have seen yesterday, we announced our X16 working with, that's our gigabit modem. So you're talking about gigabit wireless speed, working with Telstra, Ericsson, and Netgear. That solution will be delivered later this year. We also announced the X50, which is the first 5G chip. It'll be sampling in the back half of next year, but we led in 2G with CDMA, in 3G with WCDMA, obviously in 4G with LTE. We continue to lead the industry, and we're doing so again by introducing our first 5G chip. That's pretty exciting news for us. You can see what we put into R&D, and so what I just mentioned is some of the fruit of that labor. Connected vehicles are already mainstream. You're already seeing 60% cellular penetration. We expect that by 2021. To give you an idea, talking with AT&T recently, I met with the CTO. He noted that what's going to happen with regard to bandwidth requirements in cars. He said static maps, the communications in a car with a static map is about 20 kilobits per kilometer. When you go to live mapping, it's a gig per kilometer. I mean, it's just a massive increase in speeds, and you're going to need a network like 5G to accommodate that. But it's you're already seeing connectivity as a mainstream, but it's going to get increasingly that way. You see, one of the things we'd like to talk about when you look at these are the various kinds of functions that are coming into a car. But the other thing we would note is that with these connected cars, you look at what 5G is about. 5G is more or less the fabric that enables all this. If you don't have that fabric, you can't deliver some of these features. V2X is going to be another key element in terms of supporting communications between vehicles, making roads safer, and enabling this kind of synchronization I talked about earlier. What we're talking about here essentially is just what's happening, how the car evolves. Essentially, it is always on. The responsiveness, we're talking about it's one of the things you need for 5G is you need very low latency, you need very quick responsiveness. V2X is also to make sure you have very quick responsiveness between vehicles in case you're coming down the road, you want to pass a car, and there's a car that's not pretty close up the road that's coming in your direction. It'll warn you not to move out at that time and wait for that car to pass. You can see that we're really talking about V2X. This is where vehicle to vehicle, vehicle to network for downloads and updates, vehicle to people to obviously make sure we stay away from them, and then obviously vehicle to infrastructure. That's getting your lights synchronized. That's one of the concepts we talk about is how synchronized can we make this? How efficient can we make this? The more efficient, the more synchronized we make it, obviously the better our traffic flows and the more savings we have in terms of gas and emissions. As I mentioned earlier, it's the unifying fabric. That's the importance about a high-speed, low-latency network. We've talked about 5G. a year ago, and it's a different architecture than we look at current networks. Very efficient. 4G is a very efficient network, but when you think about with 5G, you're going to be dealing with multiple disparate traffic patterns: low latency, low bandwidth, low latency, high bandwidth, high latency, low bandwidth, high latency, high bandwidth. It's just these are generally mutually exclusive traffic patterns that in 5G we're going to unify all of them and manage them. That's a significant control plane architecture management issue and a challenge, but something that we're looking forward to helping solve. And that's it. So I think I got through it and ready for Q&A.
Go ahead and use this one, and I'll take this one for the Q&A.
Okay, perfect.
Do you have any questions for Brian?
Hey, Brian.
Hey, Jeff.
What is live mapping, and why does it take a gigabit per kilometer?
Essentially, that's where you're getting real-time updates. Essentially your mapping is reflective of the traffic that's in the area, where you're going. It's construction. It's taking it's essentially coordinating all of what's going on real time in the area. As you know, construction can cause lane closures. You can have accidents. It's all those things that need real-time updates and feedback. So hopefully you have fewer accidents because you've got a more synchronized system, but it's to deal with whatever's happening right then. And so the mapping itself is constantly getting updated. So you're getting that input into the car versus what you use right now is we call like the navigation system I have in my car, static. It's already in there. They may get updates once in a while to make sure that I have all the proper roads and directions in, but that's very much a system that needs very little input.
Just gigabit sounds like a lot for that. Maybe they need to look at some compression.
We like it.
It also has to do with high definition maps. So if some of these maps are
does.
created by their LiDAR sensors, and if that becomes the map, I mean, it's a question of what you call a map. Is it just a single network of roads, or are you giving contours that would be reflective of the sides of the road? And that's where the gigabit per second comes in. Robert, did you have something you want? Okay.
So what are your thoughts on the different sensing technologies? Like which ones do you see as most critical for automation, radar, LiDAR, cameras, et cetera?
It depends on your view. Right now I think there's a lot of debate on how necessary LiDAR will be. Some that have radar that are doing like CMOS radar think that they should be able to accommodate most of the LiDAR requirements in radar. Cameras certainly necessary. So at a minimum, those two. One of the challenges for LiDAR is going to be getting its cost down. We're not at it. You have CMOS-based radar now. We don't have that in LiDAR. It's a more complex technology. So, it'll depend. We definitely see camera and radar, and I think LiDAR is going to depend on the cost of it, and then what you can do with the other technologies. Up there?
Yeah, question. How is this going to scale to that one cell site just beyond the Pecos River on I-10 that only gives you GPRS service today?
Yeah, that's why I said it's going to take time.
I mean, they're still on
I know.
2G, and I'm just wondering, are you going to have the thousands of big trucks that go out I-10? How's this going to scale for autonomous?
That's where that's where people talk about autonomy happening in 5 years. We don't believe that. It's going to take time. You may see what you'll see is probably a graduated progress. You'll see initially when you have truly autonomous cars, you might see them cordoned off in their own lane, or you might see that with trucks. You might see certain conditions allowing autonomous driving. But in terms of the classes, we really see the class 4 type, fully autonomous, no human involvement, probably given all the regulatory alone, let alone some of the technology and connectivity challenges like you just described, as north of 10 years. But you'll see more and more capabilities enabled over the next several years. Another one? One more here.
Go ahead and shout it out.
Yeah.
So as far as like vehicle-to-vehicle sensing or, them exchanging data,
Mhm.
being aware of each other and keeping track of them, as the, I guess, market is transitioning towards that or, more of this technology, we have a scenario where we have, a lot of cars that are automated, and
Yeah.
a lot of cars that are not.
Yep.
Are there any current plans of how to deal with that?
Yeah.
Those cars that present with, I guess,
Real challenge, actually. You're right. They're essentially unknowns. That is where we talk about, you really to have a truly autonomous system where every car is moving, on its own, independent of the others, and level 4. You really need all of them to be there, and that's why I talked about earlier. You cordon off. I mean, I can initially see where the self-driving cars are cordoned off in a lane that are allow them to travel in that way. Certainly, we see that with trucks as well. If you look, Ericsson may have the demo. They had this demo at Mobile World Congress last year, and they were showing trucks moving in a caravan, but they also had them on their own side road. So there are techniques on that side where they can actually have them. I've seen them demo in real traffic, but it creates a challenge when you have people that are not, you don't know what, they're non-predictable. So I think initially you'll see more of a cordoned off environment for the self-driving cars. Eventually that'll flip to where if you have a car, you're the one cordoned off because you're the one actually driving it. And then eventually we get to a point, because cars last 10, 15 years on average. And there's always, there's going to be people resisting, I'm not letting a machine drive me. That is going to happen. And so it's going to take time to, have this. That's why I said it's a migration. It's gradual. It will certainly take time. But I think the convenience you'll get out of it, the time saving you'll get, the ability to work and such will drive people to want to do that. But, again, you're going to have people that just want to drive their car.
I think I saw a horse on South Congress the other day.
Truly, it's autonomous at some point.
We're keeping Austin weird and retro. Thank you, Brian. Thank you
You're
very
welcome.
much.
It's our great pleasure to welcome Sanjeev Nanda. Sanjeev has been at Qualcomm for over 10 years, and he's worked on a number of different technologies for indoor wireless, also worked on machine learning for context awareness, but recently he's been leading Qualcomm's effort on autonomous vehicles. I'll turn it over to you, Sanjeev. We're very happy that you're able to be with us this morning.